All right. We're going to solve these systems. We're going to write the solution as an ordered pair if the system has one solution. The other options would be infinitely many solutions or what? No solution. Absolutely. So we can use the elimination method or the substitution method. For this one over here on the left, I would probably choose the elimination method. I would multiply everything on the bottom by 4, because that's going to allow my y's to cancel. You're welcome, sir. 12x plus 4y equals -4. When I multiply the second equation by 4, I get 8x minus 4y equals 24. And then I'm going to add those together. What happens when I add these together? What happens to my x's? When I add those two equations together, what happens to the x's? Not degree of 2. You can never add to get a degree of 2. Adds to what, though? 12 plus 8 adds to 1? 20x. What happens to my y's? Those cancel out, because I have none left now, 0 y's. What about my constants? 20. So then I come through, I divide both sides by 20. And that means that x is what? X is 1. So right here for my ordered pair, x is 1. We still need to find y. I can use either one of these equations to find y. Which one do you guys feel like using? Bottom one, okay? So we'll use this one. 2 times that x that we just found of 1 minus y equals 6. So I have 2 minus y equals 6. Where 2 from here? Subtract 2 from both sides. Please be careful here. What's in front of that y? Negative. Bring the negative down. So I have negative y equals 4. Then I'm going to divide both sides by -1. That means y is what? -4. So x is 1, y is -4. My ordered pair, my answer is 1, -4. Please make sure that you are taking the time to read the directions on the problems. If it says it wants the answer in a very specific way, that's how you need to give your answer back. For the second one over here, I would probably also use the elimination method. Which equation would I want to multiply and by how much? Bottom one by -6. We can do that. All right, so that would give me -6x plus 6y equals 42. Guys, I need you to focus, please. Positive 6x plus 3y equals 3. So what happens when I combine these two together now? What happens with my x's? X's are going to cancel. How many y's do I have? 9y equals what? Nine y equals what? 45. I'm going to divide both sides by 9. And I get that y is how much? Y is 5. So I'm going to come down here and start writing my answer. Why is that wrong? Because it's y, not x. So it needs to go after the comma, not before it, even though it's the first thing that we found. It does not go first. It goes second. I need to find x. I can use substitution to do that. Do you guys want to use the top equation or the bottom equation? Bottom one sounds good. X minus y, which is 5, equals -7. How do I solve that one now? Add 5 on both sides. I have -7 plus 5, which gives me -2. All right. That finishes up module 2 for us. Let's go look at module 3. Come on. All right. Give me synonyms for zeros. I want all 4 synonyms. So there's zeros, there are solutions, roots, one more. Zeros, solutions, roots. What's the 4th one? X-intercepts. So when they tell me to look for the zeros on the graph, I'm going to come over here and look for my x-intercepts right here and right here. So -2, 0, and 4, 0. My vertex. Where is the vertex on the graph? What am I looking for? How do I identify it? It's either going to be where or where? Bottom or top. It's going to be the maximum or the minimum. In this case, it is the minimum right down here at 1, -9. Y-intercept, -8 right here. So my ordered pair would be 0, -8. And the axis of symmetry runs right through the center of this parabola, right through here. Where did I go through the axis at? At 1. What axis did I go through? So it's x equals 1. Tell me what axis you go through. Tell me where you went through it at. Right. Let's do some factoring work. Down at the bottom of this page, what page are we actually on now? Page 5. This will put us halfway through. How many terms does the first one have? 2 terms. So this is a special situation. We've got only 2 terms. Do I need to do the X in the box for this one? No. Does anybody remember what we call this? Yep, difference of perfect squares. What times itself gives me 4x squared? Just 2? 2x. So each of my factors gets a 2x because we're going to multiply the factors together to get this up here. What times itself would give me 25? 5 and 5, but this is -25, not +25. One has to be plus, one has to be minus. There's my factors. 2x plus 5, 2x minus 5. How do I find the solutions now that I have the factors? Set them equal to 0. 2x plus 5 equals 0. 2x minus 5 equals 0. For this one, I would subtract 5 from both sides. So I get 2x equals negative 5. Divide both sides by 2. So x is negative 5 divided by 2. The other one, because it's exactly the same, but with the opposite sign, oh, not 2/5, 5/2, is going to be positive. Because you would start off by adding 5 to both sides. All right, in the middle, how many terms do we have? 3 terms. Three terms in the middle. How do I factor something that has 3 terms? This is where I do the box and I make the x. So I'm going to go ahead and draw the box. And make my x. X squared goes here, negative 12 goes here. Up on the top of the x, I have to multiply the a and the c together. So I multiply 1 and negative 12 together. I need 2 numbers that multiply together to give me negative 12. But add to positive 4. What numbers will do that? 2 and 6. Which one should be the negative? 2. Negative 2x, 6x. So I have x and a positive 6 on one side. I have x and a negative 2 on the other side. X plus 6. X minus 2. So what are my solutions then? Where are my x-intercepts? X equals negative 6. X equals positive 2. Then we come over here, 3 terms again, so box and an x. 2x squared, negative 6. A times c, so 2 times negative 6. What is 2 times negative 6? Negative 12. Has to multiply to give me negative 12, but add to what? Adds to negative 1. No, what numbers will do that? 3 and negative 4. So I'm going to have 3x and negative 4x that go inside here. So when I go to pull my factors out, what do 2x squared and 3x have in common? Just x. Can I take a 4 out of the bottom too? No, 4 doesn't go into them both. 2 does. So x minus 2. What about 2x squared and negative 4x? What do they have in common? 2. Anything else? X. 3x and negative 6. 3. Positive 3 because it's touching a positive. I see where one of my roots is, where one of my solutions is. It's at x equals what? X equals 2. For the other one, I'm going to take 2x, unless you're talking about the content, please quiet. I'm going to subtract 3 from both sides. 2x equals negative 3. Divide both sides by 2. X is negative 3 over 2. Can you write fractions? Yeah, absolutely. Yep. I prefer fraction form over decimal form. I do prefer them to be reduced. The yellow calculators will reduce fractions for you. If you're not sure if it's fully reduced or not, you go to the fraction key So here's the green second key, 1 column over and down 2. There's a button that says N over D. If you type your fraction in there, like if I typed in 9 over 12, and then I hit enter, it will reduce it for you. So you can always make sure to have a fully reduced fraction there. All right. Go look at the next problem. Top of page 6. Find the value of C for each trinomial to create a perfect square. So what we're going to do is we're going to take this middle number right here. To create a perfect square, we will cut it in half. And then we will square it. So I'm going to take -8. I'm going to cut it in half. And then I'm going to square it. What happens if I take -8 and I cut it in half? I get -4. What does it mean to square something? Times it by itself. What is -4 times another -4? +16. So the value of C that we were looking for is 16. Over here in the middle, same exact path. I'm going to take this middle number, 14. I'm going to cut it in half. And then I'm going to square it. What is 14 cut in half? 7. I need to take 7 and square it. I'm going to multiply it by itself. And so I would get 49. So C is 49. Very last one. What happens when I cut that number in half? I get 20. And 20 squared is what? You said 400? Yep. So C is 400. Number 17, we're going to use quadratic formula. This is something that you might want to put on your cheat sheet, as I will not give you any formulas at all on the exam. Quadratic formula. If you want to put that on your cheat sheet, x equals -b plus or minus the square root of b squared minus 4ac all over 2 times a. That fraction bar is really, really big. It goes underneath everything in my numerator. You can't do the whole thing in the calculator. You can do part of the top part in the calculator. I'll show you how to do the calculator part. All right. Where do I go for A, B, and C? Where do I go to get the values for A, B, and C that we're going to sub in? Well, this tells me where they go. Where do I get the numbers to put in there? The equation. Which one of those is my value for A? 3x squared. I look for my x squared. There's A. What's my value for C? -1. And my value for B? -4. We don't put the x's in with them, just the numbers. The X is over here. We just want the numbers for A, B, and C. It is going to. So I'm going to substitute in just what I see for starters. But anywhere I make a substitution, I'm putting parentheses. Anywhere we are substituting in a number, I have parentheses holding that spot. What do I put right after the minus sign in that first set of parentheses? What's the number that goes there? -4, because it says negative B, and B is -4. What goes in the second set of parentheses, the ones that I'm squaring? -4 again. What goes right here next to the end? What number do I put right here? 3. Remember, we only substitute numbers in, no X's. What do I put back here? -1. What about down on the bottom? 3. All right. Talk to me about what we can do here. What can I simplify? The -4. Negative and a negative is going to make what? Positive. So I have X equals +4 plus or minus. Can I simplify anything underneath that radical? -4 squared, what does it mean to square something again? Times it by itself. -4 times another -4, +16. And then I have a minus sign right here. So I'm going to bring my minus sign down. 4 times 3 times -1. 12. I have that -1, so I have a -12. Because I just brought this minus sign down right here. I brought this minus sign down, so I did 4 times 3 times -1. If you look at it as a -4, there's nothing wrong with that, but you would just be simplifying this part in the step above. So you should still end up with 16 plus 12. So I'm going to bring my work over here. I have X equals 4 plus or minus the square root of 16 plus 12 all over 6. What is 16 plus 12? 16 plus 12? 28 over 6. Is 28 a perfect square? No. Can I break it down at all? Are there things that go into 28? Yes. So let's break that down. What goes into 28? 14 and 2. Is 14 a perfect square? Is 2 a perfect square? No. Can I break either one of those numbers down more? 14 can become a 7? 14 and 7 aren't the same. How do I make a 14? 7 times 2. So 7 times 2 times 2. If I do 7 times 2 times 2, is that 28? 7 times 2 times 2. Yes. Because 7 times 2 is 14 times another 2 is 28. Do you guys see anything multiplied by itself in here? I see 2 times 2. 2 times 2 is 4. I'm looking for things that are multiplied by themselves because I can take the square root of those. I would have the square root of 7 times the square root of 4 Is 7 a perfect square? Can I break it down any more than that? No. Is 4 a perfect square? Yes. What is the square root of 4? 2. So I have 2 square root of 7. That is going to take the place of this square root of 28. So I have x equals 4 plus or minus 2 square root of 7 all over 6. We almost have this in simplified radical form. I need to try to reduce this fraction down. I have to distribute with division the same way I would distribute with multiplication. So I'm looking at this right here. Do 4 and 6 have anything in common? Can I reduce that at all? What can I take out of both of them? 2. So I would have 3 in my denominator and 2 in my numerator. And then I'm going to look this way also. I can look at numbers that are outside of radicals and I can reduce them, or I can look at numbers that are just inside of radicals and I can reduce those. Face forward, please. Face forward, please. Do 2 and 6 have anything in common? Can I reduce those at all? 1 and 3. So I have 2 plus 1 square root of 7 over 3, 2 minus 1 square root of 7 over 3. 2 over 6 reduces to what? 1 over 3. Here's where you can pull your calculators out. Now, I don't have to write down the 1 in front of the 7 if it's just a 1, sorry, in front of the square root of 7. Grab your calculators for me. I'm going to show you how to put this into your calculator. You need the fraction key. So again, here's the green second key. Go 1 column over and down 2 buttons. It says N over D. That's your fraction button. That's what you want to press. And then up in your numerator, let's put this one in first. 2 plus. And then how do I make it to a square root again? Second and x squared is how I get my square root button. And I put a 7 in there. How do I get down to the denominator? Yep, use this round keypad here. We're going to push the down arrow. And I want 3 in my denominator. Hit enter. Second, so the green button, and x squared. The problem when I hit enter is that I still don't see a decimal. How do I make it show me the decimal? The arrows right above the enter key, we're going to push these back and forth arrows. You should get 1.5485. You hit enter and it gave you something that wasn't a decimal, right? Push the button right up above enter key now. There you go. I want you guys to do this, but with the subtraction one now. Same exact process, but do it with subtraction. Anybody have an answer for me for the -1? Is it a positive or a negative number? Negative. What comes before the decimal?
Before decimals.
Negative 0.21 if I take it out a couple extra digits, just so you guys can make sure that it matches what's on your calculator screen. On the exam, you need to always be giving me 3 numbers after the decimal point. That way, if it's off by just a little bit, or if I'm not sure if you rounded, I can compare your numbers to my numbers. All right. So give me at least 3 numbers after the decimal point so I can make sure that yours and mine match. All right. Bottom part of the page. Let's do some operations with complex numbers here. Oops, a little bit too far. There we go. On part A, on number 18, what is it asking us to do to these 2 numbers? What's in between these 2? Addition. This one right here, we want to add these 2 together, so I'm going to line them up. 4 plus 7i. I'm going to put like terms underneath each other. So 2 and minus I. And I'm going to add them. So I get 4 plus 2, which is 6. And I have 7i minus I. 7i minus I would be what? 6i. What are they asking us to do on part B? What operation do they have here? Subtraction. How do I deal with that? I'm going to subtract them, or I'm going to distribute this, and then I'll line them up and combine again. So negative 5, but this would become a plus 2i. So I have negative 1 plus 3i. I have negative 5 plus 2i. I line them up with like terms underneath each other and combine. Negative 1 and negative 5, what do I get when I combine those? Negative 6 plus 5i, you're absolutely correct. What operation is going on in part C? That one is multiplication. So I'm going to use double distribution here. I'm going to take this 3 and distribute it to the 2. So that would give me 6. 3 distributes to 5i. I get 15i. Then I take 2i and I distribute it to the 2. So plus 4i. 2i times 5i would be 10i squared. Do I have any like terms that I can combine together? 15i and 4i. There's something else that I notice, and it's this I squared. I squared is the same thing as what? Negative 1. So I have 6 plus 19i plus 10 times negative 1. What is 10 times negative 1? So 6 plus 19i minus 10. Do I have any like terms again? Yep, I have 6 minus 10. What is 6 minus 10? Minus 4. So negative 4 plus 19i. All right. I is equal to the square root of negative 1. So anytime I see a negative underneath my radical, I'm going to take it out as I. So right here and right here. So I have I square root of 25 times I square root of 4. Now I'm going to multiply these together. I multiply I and I, since those are both outside of the radical. I get I squared. Square root of 25 and square root of 4 becomes underneath the square root, 25 times 4. What is 25 times 4? 100. So underneath my square root, I have 100. What can I replace the I squared with? -1 times the square root of 100. What is the square root of 100? What is the square root of 100? 10. -1 times 10, I get -10. On part E, I'm going to approach it almost exactly the same way. The negative underneath the radical, those are both going to come out as i's. So I have I square root of 9 times I square root of 8. Multiply I and I together, I get I squared. Multiply the square root of 9 and the square root of 8 together, 72. I squared, I replace with a -1. Is 72 a perfect square like 100 was? No, then I've got to come over here and break it down. What do you know of that goes into 72? 8, okay. So 8 and 9. Can I break down 8 anymore? 2 times 4 times 9. Is 2 a perfect square? No. Is 4 a perfect square? Is 9 a perfect square? Yes. So I can break this down to be the square root of 2 times the square root of 4 times the square root of 9. What is the square root of 4? So I have the square root of 2 times 2. What's the square root of 9? 3. What's 2 times 3? So I have 6 square root of 2 times -1. That would be -6 square root of 2. Guess what you guys told me? That's the square root of 2. That's the square root of 4. Square root of 4 is 2 out from underneath the square root because we did that operation already. This one, you can't do the square root of 2. It comes out to be a decimal on your calculator. Does that make sense? If it's a perfect square, we can take it out. If it's not a perfect square, it has to stay underneath, and then we can't do anything with it, really. All right. I think we have 4 more problems, and we'll finish up module 3. All right, we want to find the value of the discriminant. This is something else that you might want to put on your cheat sheet. The discriminant is b squared minus 4ac. Now, if this comes out to be a negative number, then that means there are 2 complex roots. If this comes out to be a positive number, then there are 2 real roots. And if this comes out to be 0, then there is 1 real root. This information right here, I would make sure is on my cheat sheet if I were you. Very important module 3 information. Before I can do b squared minus 4ac, this right here must be equal to 0. I cannot get the right A, B, and C values if it's not equal to 0 first. What do I need to do to both sides to make it equal to 0? Subtract 10 from both sides. So I'm going to minus 10, minus 10. That is not a like term with anything else that I already have. So x squared plus 2x minus 10 equals 0. Shh, guys, please focus. What are we using for A, B, and C? Super close. Negative 10 is C. When we plug into the discriminant, do I want to take the x's with me? No. 2 is B. Put it up, please. So what is A? 1. All right. A is 1, B is 2, C is negative 10. So we're going to substitute into the discriminant. Remember, anytime I substitute, use parentheses. So we're doing B squared, so 2 squared minus 4 times A times C. What is A again? 1, and C is negative 10. What is 2 squared? 4. Bring down my minus sign. 4 times 1 times negative 10. Negative 40. It's going to become a positive because I'm subtracting a negative. So I have 4 plus 40. What is 4 plus 40? 44. What kind of roots do I have then? Two real roots. All right, let's do down below. What has to be true about this first? Equal to 0. I don't ever like it when my x squared is negative, so I'm going to leave that one where it's at. So x squared equals 2x minus 4. If I want it equal to 0, I need to minus 2x from both sides. So x squared minus 2x equals negative 4. Do I have it equal to 0 yet? Did I get it equal to 0 yet? No. What do I still need to do? I'm going to add 4 to both sides. Do you guys remember why I said I'm doing it this way instead of minusing x squared? I don't want to make the x squared a negative. So what is my A value? 1. What is my B value? Negative 2. So 1 is A. Negative 2 is B. And what is C? 4. All right, so let's plug into the discriminant. B squared minus 4 times A times C. So I have negative 2 squared minus 4 times 1 times 4. What is negative 2 squared? Negative 2 times itself. 4. Bring down my minus sign. 4 times 1 times 4. Yep, so I have 4 minus 16. What is 4 minus 16? Negative 12. So what does that mean about my roots? 2 complex roots. Let's do one more like that. First, I need this to be what? Equal to 0. So how do I get this equal to 0? Minus 4x on both sides. That cannot combine with either of my other terms because they are not like terms. What is our value for A? 4. What is our value for B? -4. And what is our value for C? 1. So let's substitute into our discriminant formula, b squared minus 4ac. So b is -4. So -4 squared minus 4 times a times c. What is -4 squared? 16 minus 4 times 4 times 1. 16. 16 minus 16? 0. What does that mean about my roots? 1 real root. All right. Let's do 22 and then we'll stop here for today and we'll do 4 and 5 on Monday. Does that sound reasonable? All right. So we are supposed to solve this system. When you go to solve systems, we have 3 ways of solving those. The first way is graphing. But if they didn't give you graphs to draw on, I would not choose graphing as my method. We have substitution. I want either x alone or y alone if I'm going to use the substitution method. Or elimination. And that's what we did earlier today on those module 2 problems, number 12. Which one makes the most sense here? Substitution. So I'm going to take x squared, and it's going to take the place of the y in this other equation here. So I'm going to have x squared equals 2x plus 8. I need to get this equal to 0. So I'm going to minus 2x from both sides. Remember, I don't ever want my a value to be a negative, so that's why I'm minusing the 2x. X squared minus 2x equals 8. How do I get this equal to 0? Minus 8 from both sides. So x squared minus 2x minus 8 equals 0. We're looking for solutions, so I'm going to do the x and the box. So I have x squared -8. I multiply a and c together, so 1 times -8. I need 2 numbers that multiply to give me -8, but when I add those same 2 numbers, I get -2. What will do that? -4 and +2. So -4x, +2x. So x minus 4, x plus 2. We were asked for solutions here, so I need to take those and set them each equal to 0. So x minus 4 equals 0. X plus 2 equals 0. So what are my x's? Guys, shut the stuff off. It's rude and distracting.
4 and -2.
4 and -2. But just like when we solved the systems on number 12, I need not just the x's, I also need the y's. So we're going to have to substitute back into one of these 2 equations to find our y values. Do you guys want to use the top equation, y equals x squared, or use the bottom equation? Top one sounds fine to me. Y equals, and then I'm going to substitute in what we found for x, which was 4. And then I'm going to square it. What is 4 squared? So y is 16, which means I have an ordered pair solution at 4, 16. And then we need to do the same thing with our other solution for x. Y equals, and I've got -2 in here. What happens when I take -2 and multiply it by itself? I get 4. So -2, 4 is my other solution. All right. We're going to kind of put things on pause here. The bell's getting ready to ring for our D-Lunch study time. On Monday, we'll do modules 4 and 5. That'll finish up your packet. You guys should be working on your cheat sheet so that you have that to use for your exam on Tuesday. On Tuesday, after A-Lunch, right when you guys walk in the room, I will hand you your final exams and you'll start taking your tests. All right? Tuesday. Oh, last day of school. My apologies. I couldn't hear you very well. Thursday is our last day of school next week. I'll put this right back up. I'm just going to stop recording.